All right, we're going to keep going. We're going to try to get through this whole section. You may have to break it up. Give yourself a brain break at some point. 27. Now we're dealing with these numbers when they are under a root. This is going to be a little bit different. We're going to have to get, we do not like, this isn't just Abeka, this is all algebras. Nobody likes to have radicals on the bottom. So let's get them out of the bottom. That is against all algebra etiquette, I think. Okay. So what I did there was I basically just multiplied this fraction by 1. That's okay to do. I'm not going to change it. I'm just making it times square root of 5 on the top, times square root of 5 on the bottom. So my top will be 4 times 5. That's just square root of 20. They stay under their root because they're both square roots. They will stay under that root. And I've written my 20 on the bottom. Square root of 5 times square root of 5. Wow, that's going to make square root of 25. We know what that is. Now we won't have to deal with a radical on the bottom. So we've got square root of 20 over 5. Great. Now we are a lot simpler. Well, not necessarily simpler, but we don't have the radical on the bottom. Now we can worry about simplifying the top. Square root of 20 should be familiar. We did that way back in problem 1, actually. That's just 4 times 5. Still over a whole 5. Square root of 4 times 5 over 5. Well, one of these can come out to be a 2 times the square root of 5 over 5. Remember, Abeka would have you write your radical out kind of to the side. So this is how Abeka would like it written. 2/5 times the square root of 5. The square root of 5 is sort of off to the middle, but it still counts as being in the numerator when you see something written like that. That is the correct way to write it. That was pretty easy. All right. Okay, let's do number 29. Again, we've got something over something. And this radical, I'm writing it to where it covers the whole fraction. You could write it either way. You could write one radical over another radical. Since they're both square root radicals, one of them's not a cubed, it doesn't matter. You can write, since they're both of the same index, you can write them both like that, like the book has it. All right, cubed root of 5 over 6. Let's start by getting that 6 out of the bottom so that it is not a radical on the bottom. If you have something 6 to the 1 and you want to get it out of a cubed root, you need something cubed. Just like we had 5 to the 1 and we wanted out of a square root, so we made it 5 to the 1 times 5 to the 1 so we could get 5 to the 2. Because something to the 2 under a 2 index will just come out. Something under a 3 index needs to be to the 3. So we've already got 6 to the 1. We need just a 6 to the 2. 6 squared, which is 36, right? If you multiply 6 times 6 times 6, you've got 3 6s. And they will come out of there. That's all we're looking at right now, is get that bottom clean of radicals and get it to be a whole number. So 36 on the bottom, 36 on the top, because I don't want to change my fraction. Then I wouldn't be doing correct math. I want my fraction to just get the same amount bigger on top and bottom. So that's why I multiply 1. Something over something, same thing, to be 1. Okay, sorry to get so long-winded. All right, so the bottom is just going to be 6 times 36. 6 times, I'm going to write it like this. I don't know what 6 times 36 is. I don't really care. It's going to be out of my hair in just a second. 5 times 36. I do need to find out what that is. 5 times 36 is 180. That's cool to know. 180. Now, my 6 to the 1, and this is just 6 to the 2. My 6 cubed will come out of a cubed root. My 180 is still under a cubed root up here, but my 6 cubed came out to be just a 6. Now we can actually look at the 180 and say, what's a way we can get a perfect cube out of here? Perfect cube of 180. Or something inside 180. What do we have there? 27 is perfect cubed of 3. Perfect cubed of 5 is 125. Perfect cubed of 6. Maybe I will do that after all. 6 times 6 times 6 is 216. Too much. Let's go back down to perfect cubed of 4. 4 times 4 times 4. 64. I wonder if 64 will go in there. I kind of doubt it. 180 divided by 64. No. Perfect cubed. Maybe we better try 27. 180 divided by 27. 180 divided by 27. Maybe divided by 8. Well, you know what? It just occurred to me. I see what factors are in 180. 5 and 36. If I break them down into the lowest prime numbers, it's 5 times 36 is made up of 6, which is 3 times 2, and another 6, 3 times 2. That is the base everything that makes up 180. I cannot get a cube out of any of this. There's not 3 of any of the same thing. So really, it took me that long to just show you that 180 cannot be broken down into a cubed root anymore. So all we're going to worry about doing is writing this the way Abeka would want, which is fraction, radical to the side. So yeah, there's a invisible 1 always. So 1/6 times the cubed root of 180. That was a real stumper for me. And I'm going to check the work because I want to be sure I got that right. 1/6 times the cube root of 180. That is right. All right, 31. Let's move on down the line. 31. 3. Can you see that? Yes. 31 is 3x cubed over 2y, all under a square root. 3x cubed over 2y, square root of all that. Okay, let's get the 2y out from the bottom. I'm going to start working these a little faster. 2y over 2y under a square root. Multiply them together at the bottom and the top. And let's see what fraction we end up with. Square root of 2y times square root of 2y. Well, it just comes to 2y. When you multiply 2 square roots together, they square out to be, I'll write this 4 squared. We know it's going to come out. All right, the top, 3x cubed times 2y, that comes to 3 times 2 is 6. X cubed times y is x cubed times y. All right, so let's take the 4y squared out of there. Square root of 4 is 2. Square root of y squared is y. So now our bottom is a regular number, not under a radical. That's awesome. And our top is 6x cubed y. Can we do anything with the top? Can we get anything out of there to make this more simple? Actually, yes, there's x cubed. Some of it can come out. If you break it down into, okay, I'll just do it out here. If you break x cubed into x squared times x to the 1, you can take the root of x squared So the 6 will stay under. Just the x to the 1 will stay under, and the y will stay under. But the x squared comes out from under the radical to make simply x. All over 2y. Alright, let's write it the way that makes Abeka happy. X over 2y times the square root of 6xy. Okay. That is your answer. Alright, let's do number 33. Okay. That is, okay. Cube root of 2x cubed y squared over 9b squared. 2x cubed y squared over 9b squared. Okay, let's think about all the... Actually, let's think about getting this 9b squared out from under here. We need it to be a cubed-ish number. 9 is a square. It's a perfect square, 3 times 3. B squared is a perfect square, b times b. In order for them to be a perfect cubed, we need one more of each one of these. So, we're going to multiply top and bottom of our fraction by what helps us out. One more 3, because remember 9 is just 3 times 3. B squared is just b times b. We want another 3 and another b. So let's just write 3b. And of course, under a root. They have to be under the root to be of the same order index to make this work for us. Alright, so 9b squared times 3b. That will come out to, if you do it all the way, 9 times 3 is 27. I'm just going to write it big like this. B squared times b is b cubed. Now look, that's just going to come out perfect when we take the cubed root of it. Alright, now we got to do the top. They suffer the consequences as well. Makes for a bigger top. Okay, 2 times 3 is 6. X cubed y squared b. That's what we got at the top now. Alright, let's simplify our bottom. Cubed root of 27b squared is 3b. Just a 3b on the bottom. That's nice. Oh, what happened there? 3b. Okay. And the top is going to be cubed root of 6x cubed y squared b. 6x cubed y squared b. Alright, I see one thing that will come out from there, and that's just the x. Because x cubed, cubed root of that, is just x. So our answer, x over 3b, and I write anything under the radical to the side, it still counts as being in the numerator though. Answer to number 33 is x over 3b times the square root of 6y squared b. Okay, let's do number 35. We are so close. Okay, number 35 is cubed root. Let me write my radical. Cubed root of, I'll make sure this is focused. Okay, cubed root of 2a over 3b squared. Okay. Alright. Cubed root. We need all of these to be perfect cubes. B squared is almost there. 3 needs some help. They both need some help, but 3 needs more help. Okay, 3 needs 2 more 3's. So I'm going to write 3 times 3. I'll write 3 squared instead of 9, just so that you see that we're thinking 3's. And b squared needs another b. So the cubed root, don't forget to write the same index, of course, so that they match. You can actually multiply them together if they're the same index. Top and bottom are the same for this little fraction we're using.
Night, Katie.
Night.
Makes a neat light down here when you're up there.
Alright, 3b squared
Oh, sorry.
times 3 squared b. That's okay. Okay, top. The top will come out to be cube root of 2a times cube root of 3 squared b. 2 times 3 times 9 is 18. A times b is ab. Alright, bottom. 3. Bottom is the cubed root. I just chose to make my top and bottom radicals under separate little houses. I could have written them together because of course they're both cubed roots. It's just how I wanted to write it. Alright, 3 times 3 squared, that's 3 cubed. B squared times b is b cubed. Now we're just right and ready to take that out of there. Bottom is now going to be cube root of 3 cubed is 3. Cube root of b cubed is b. The top is cubed root of 18ab. There, 18 is made up of 6 times 3. There's nothing in there that can be cubed down. So really this is as far down as we can go. We can write it the way they want us to though, which is 1 over 3b times 18ab. Here we go. Alright, let's do 37. A plus b times square root of a plus b times over a minus b. Square root of a plus b over a minus b. Okay? Let me focus that. Alright, we know that we need our a minus b to get out of that radical. So let's take care of that. Top and bottom, I'm going to multiply by, since this is square roots, it's so easy, we just need 2 of the same thing. Square root of a minus b over square root of a minus b. Alright, let's just do the math. Write out your top. I'm going to write them separately. So I start messing with one and the other. A plus b times a minus b over a minus b times a minus b. That is all under a root, of course, still. A minus b times a minus b is just a minus b squared, which is going to come out of a root. Yay. A plus b times the square root of a plus b times a minus b all over a minus b. Okay. I'm wondering if there's any other way that we can simplify anything else. A plus b times a minus b, that comes to a squared minus ab. Okay, let's do this math. I think we might can factor this out a little more. Okay, let's write our a plus b that's on the outside. Let's write our square root, and let's just do this math of these two. A times a is a squared. A times negative b is negative ab. B times a is positive ab. Okay, these are going to negative ab, positive ab. That will just zero each other out if you add them. It's like saying negative 3 plus positive 3 is 0. Negative b squared right here. Okay, all over that a minus b that we found. Okay, let's bring it down another step and just write it clear for ourselves. A plus b times the square root of a squared minus b squared. All over a minus b. So really, there's not a way to actually get anything else out from under here. but we have written it as simply as we can. Got rid of those ABs that would zero out. Now all that's left is to write it the way Abeka would like, which is scoot your radical out to the side. A plus B over A minus B being multiplied A squared minus B squared. We can't take them out of a radical. We can't take them out. You might say, well, A squared, the square root of that is just A. That works when you're multiplying stuff. Like if you had A squared B squared like that, yeah, you could take it out and make it AB. But when they're being plussed, you have to, you can't just take stuff out like that. Hopefully you can just take that rule and know it's there, and one day it'll make sense. Right now I'm just trying to get the basic working this problem. Alright, last one, because we're doing odd numbers. Ooh, and it's busy. Okay. A plus B squared over A minus B. All multiplied times the square root of A plus B over A minus B being squared. Just the bottom one being squared. Okay. Alright, let's break this apart. Oh, and it's the cubed root. Whew. Okay. So what have we been looking at? The first thing we always look at these problems lately has been what's on the bottom, what's on the bottom. Stop it from being a radical on the bottom. Alright, so really I needed some more space right here. I'm going to rewrite that whole problem just for more space. You be stewing and thinking on what you can do to the bottom while I rewrite this. A plus B squared over A minus B times the cubed root of A plus B over A minus B squared. Interesting. The bottom is something squared, yet it's under a cubed root. The index is a cubed. This is a squared. I wish it were a cubed. That way I could take it out of the radical. How do I make it a cubed? Multiply it by just one more of its base, and you'll have A minus B squared times A minus B. That'll be A minus B cubed, and we can take it out. So if I've got A minus B at the bottom for this little special radical that I'm multiplying the whole thing by, I need A minus B at the top. It's just the way it works, so that this whole fraction just means 1. Something over the same thing is just 1. Like 3 over 3. That's saying 3 divided by 3. Goes into itself one time. So anyway, A plus B squared, you knew that, over A minus B. Alright, let's do our math at the top. I'm going to write it under a separate radical because I want to. A plus B times A minus B. Oh, and of course you want to write your same index so that this index and this index match. Okay, forgot about that. A minus B times A plus B times A minus B under a cubed root makes just that. A minus B. We'll work that out in the next step. Under here, we're going to write A minus B squared times A minus B. That just makes A minus B cubed under a cubed root. Alright, next step, we're bringing it all down again. A plus B squared times the cubed root. Now I will break these apart and go ahead and multiply them out. A plus B times A minus B. Let's do the math. A squared, multiply the A times the negative B, negative AB, B times A, positive AB. This is just like that last one we did. It's very similar. B times negative B is negative B squared. So negative AB and positive AB, that's just, yeah, that's just 0. So we only have these two. And on the bottom, cubed root of A minus B cubed is just A minus B. A minus B. Alright, let's bring it all down again. a plus b squared times the cubed root of a squared minus b squared, all over a minus b. All right, I think we're very close to being done, if not done. Expanding this would not really make it any simpler. That cannot come out of a cubed root. That's not a radical anymore. So, but upon glancing at the answer key, I noticed that I forgot to bring down something from my problem. Let's look back up here. I brought that down, brought that down, brought that down. This right here, I just totally forgot about that a minus b. You probably noticed it, and great for you. Let's go ahead and bring that down, a minus b. So really what happens to it is, I didn't write that really on the line, but it's a minus b. Because remember, it came out of being an a minus b cubed under a cubed root. So really we got a minus b times a minus b, that's a minus b squared. That little detail would have gotten me that problem wrong. Or it did get me that problem wrong. But now that we've written that out and carried that down and got all that right, there really isn't, we don't need to expand anything else. That's the answer to our problem. Nothing will cancel. That's a plus, that's a minus. They're not the same, or they'd cancel. That doesn't. All right, so let's just write it out the way Abeka would like. A plus b squared over a minus b squared, all being multiplied. The radical cubed root of a minus b squared. And it isn't a minus b being squared, it's just a minus a. Oh wow, this squared from the a didn't bring that down. What is with me tonight? Alright, let's double check all this in the answer key. Make sure I'm not telling you wrong. Alright, the answer from the answer key is a plus b squared all over a minus b squared times cubed root of a squared minus b squared. We got it. Good work.